Let us look at order of a group and order of an element of the group. Now, the number of elements of a group is called the order of the group. We write it as O of G or G between two vertical bars. Now, the order of an element, that is O of A or A between two vertical bars, is how many times you need to apply the group operation to the element to get the identity. So if A is in G, A to the power of n is equal to E, where n is the least positive integer. Then n is the order of the element A. Now, if there is no such n, then we say that the order of A is infinite. And if there exists n, such an n, then order of A is less than or equal to n, where A is in G. N times A is equal to E for additive groups, and A to the power of n is equal to E for multiplicative groups. We have already seen how we represent additive groups and multiplicative groups. Now let's look at some of the properties of these orders. Order of inverse. Order of A inverse is equal to order of A. That is, the order of an inverse of an element is the same as the order of the element. So again, we can write it like this, or we can write it like this. Divisibility rule. If order of A is equal to n, then A to the power of m is equal to E if n divides m. So which means m here is a multiple of n. If order of A is equal to n, then m times A is equal to E, which implies again n divides m. So this is for the multiplicative notation, and this is for the additive notation. Order of products. Now this is applicable only for multiplicative groups. Order of A times B is equal to order of B times A. Although order of A times B may not be equal to order of A or order of B. Now, just like we have order of products for multiplicative groups, we have order of sums. So that is written as order of A plus B is less than or equal to the least common multiple of the order of A and the order of B, when group is cyclic or abelian. Power and co-prime rule. If order of A is equal to n and k is in the set of integers such that the greatest common divisor of k and n is equal to 1, that means the k and n are co-primes, then order of A to the power of k is equal to n, and if the GCD of k and n equal to 1, then the order of k times A is equal to the order of A, which is equal to n. Again, this is for the multiplicative group and this is for the additive group. Order of a power in general. Here we were talking of with the co-prime. Here it is in general. If order of A is equal to n, then order of A to the power of k is equal to n divided by the GCD of n times k. If order of A is equal to n, then order of k times A is equal to n divided by GCD of k and n. Again, multiplicative notation and the additive notation. Now, conjugation does not change the order. So if we have an element A, and if we do the conjugation, now this is applicable to specific groups. Typical example is your matrices. So matrix multiplication is not commutative, which is what non-abelian groups mean. So we have order of x inverse times A times x is equal to order of A. So when we do the conjugation of an element, it doesn't change the order. Now, of course, in case of abelian groups, conjugation is trivial. Since it is abelian, that means it is commutative, we can directly cancel off x inverse and x. So we are left with A. So that was order of a group and order of an element and properties of orders of an element. Again, let me remind you, there is a link to a PDF book which describes all these in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.